Welcome back. In this video, we are going to work on simplifying algebraic expressions. We're going to begin with some more vocabulary, starting with term. Term or terms are a number or the product of a number and variables raised to powers. And terms are generally added and subtracted and not multiplied amongst each other. Now there is product implies there's multiplication within terms, but we will generally add and subtract terms. There's something that are added and subtracted. So some samples of some terms. Negative x is a term, or 2y cubed is an example of a term. The integer negative 5 is a term. 3xy squared could be a term. You can even have fractions in terms. 1/4 x squared y cubed. Okay, so all those are different examples of terms. The coefficient of a term, the coefficient is the numerical factor in the term. So this is 2 times y cubed, or this is negative 1 times x. So our coefficients here, like this one, would be negative 1, or 2, or 3, or 1/4. So the highlighted things, I would consider those the coefficients up in our samples of terms. So negative 1 from above, 2, 3, and 1/4, those would all be considered the coefficients. Like terms. Like terms are terms with the same variable and the same exponents on those variables. So some examples of like terms might be 3x and 2x. We could add or subtract those, and we'll talk about that here below. Something like 6x squared y cubed and negative 1/4 x squared y cubed. Those would also be like terms. We have the same variables x and y, and we have the same exponents on those variables. On x we have the second power, and y we have cubed. Coefficients can be different. Now if we had something different in this example, like if we had 6x cubed y squared and negative 1/4 x squared y cubed, well, those are unlike terms because even though I have the same variables, I've got different exponents on those variables. So those are not like terms. So even if this was y squared, well, they're still not like terms because the x cubed doesn't match the x squared. So that's an example of some unlike terms. We can combine like terms by adding and subtracting only the coefficients of those terms. That's how we combine like terms. We cannot combine unlike terms. They stay separate. So we will add the coefficients. So if we had something like, 5y minus 3x plus 6x, well, I don't have any like terms to go with the 5y, but I do have these two x's here, and negative 3x plus 6x is plus 3x. So that would be simplifying and combining like terms. We can do that with fractions. 2/3 x minus 2x. Well, those are like terms, and that is what? Negative 1 and 1/3 x. I probably would like to call that a negative 4/3 x. Hopefully my arithmetic is right. Yeah, because 2 is 6/3, so I'm good. Other things you will have to do in this section, you might have to find a product by distributing. Okay, so the distributive property, we saw that in an earlier unit. This is an example. We might have 3 times the quantity 11y plus 6. Well, our distributive property says we have to multiply every term in the parentheses by the 3. So that would be 33y plus 18. Okay? Or if we had something like the opposite of 3x plus 2y plus z minus 1, well, this is like a negative 1 in here, and we would impose that on every single term inside the parenthesis. So subtracting a quantity is like multiplying an entire quantity by negative 1. So we get negative 3x minus 2y minus z plus 1. It doesn't look like they have any like terms to combine. So subtraction and distributing a negative, there are some commonalities in there. We will see that subtracting algebraic expressions is fraught with peril. So for example, if I asked you to simplify negative 3 times 7x plus 1 minus the quantity 4x minus 2. Okay, this minus sign here is fraught with peril because we have to remember to take the opposite of both the 4x and the negative 2. We've got to apply that negative all the way through. Right? Aren't we going to apply the negative 3 all the way through here on the left? We are. So we get negative 28 1x minus 3 minus 4x, and then minus a minus 2 is plus 2. So negative 21x minus 4x, I think that's negative 25x minus 1. Here's another one that seems to trip up students every once in a while. 8 plus 11 times the quantity 2y minus 9. Okay, I don't have fraught with peril here, but this 8 plus 11, the temptation is to call that 19. Well, that violates the order of operations. So you got to be careful there. The order of operations say we cannot do that. We have to multiply the 11 first. We have to do multiplication before we do any addition and subtraction. We have to do parentheses before we do multiplication, but the parentheses here we can't simplify. So we're going to go to multiplication. Remember, PEMDAS. So here's our multiplication. Okay, our addition, we don't want to do that. That comes later. So no addition. Wow, that's getting messy. So we have 8 plus 11 times 2 is 22y minus 99. And now we can combine our like terms. We get a very different answer here. We get 99, negative 99 minus 8, would that be negative 91 plus 22y. And we've simplified, those are like terms. Also in this section, we're going to be translating phrases into algebraic expressions. So here are some samples of that. For example, 3 times a number subtracted from 10. 3 times a number subtracted from 10. Well, 3 times a number is 3x, but we're subtracting from 10, so that must mean we're starting with 10. So that is 10 minus 3x. Number 2, 7 times the difference of a number and 4. 7 times the quantity, the difference of a number and 4 is x minus 4. We distribute the 7, and we get 7x minus 28. Number 3, 3 times a number added to the sum of a number and 6. 3 times a number is 3x. And we're adding 3x to the sum of a number, it must be the same number, and 6. So 3x plus x plus 6. We don't really need the parentheses here, so we get 4x plus 6. And that's all simplified. Expression 4 and 5. The question here at the bottom says, are the expressions in 4 and 5 above equivalent? Why or why not? Well, let's take a look. 4. 4 subtracted from 3 times a number. So we must be starting with 3 times a number. So 3 times a number, and we're going to subtract 4 from that. That's 3x minus 4. That's all simplified. Number 5, 3 times a number is subtracted from 4. Well, we must be starting with 4, and we're subtracting 3 times a number. So 4 minus 3x. So our question, are the expressions in 4 and 5 above equivalent? Why or why not? Well, I'll let you mull that over, and you can answer that question when I see you in class.